All right, everybody. Welcome to Antennas. So 5 sections, 106 questions. Yikes. First eye chart, band or beam width and pattern ratios, radiation and ohmic resistance, feed point impedance, and antenna efficiencies. Lots of basics of the antenna is going to have several continuing here. So we'll just jump right in. What is an isotropic antenna? A grounded antenna used to measure Earth conductivity. B, a horizontally polarized antenna used to compare Yagi antennas. C, a theoretical omnidirectional antenna used as a reference for antenna gain. Or D, a spacecraft antenna used to direct signals towards the Earth.
Charlie.
Charlie is correct. How much gain does an antenna have compared to a half-wavelength dipole when it has 6 dB gain over an isotropic antenna? A, 3.85 dB, B, 6.0 dB, C, 8.15 dB, or D, 2.79 dB.
Alpha.
Alpha is correct, 3.85 dB. How does the total amount of radiation emitted by a directional gain antenna compare with the total amount of radiation emitted for a theoretical isotropic antenna, assuming each is driven by the same amount of power? A, the total amount of radiation from the directional antenna is increased by the gain of the antenna. B, the total amount of radiation from the directional antenna is stronger by its front to back ratio. C, they are the same. D, the radiation from the isotropic antenna is 2.15 dB stronger than that from the directional antenna.
Charlie.
Charlie, they are the same. What is the far field of an antenna? A, the region of the ionosphere where radiated power is not refracted. B, the region where radiated power dissipates over a specific time period. C, the region where radiated field strengths are constant. D, the region where the shape of the antenna pattern is independent of distance.
Charlie.
Delta.
Delta.
Delta is the correct answer. The region where the shape of the antenna pattern is independent of its distance. In the antenna radiation pattern shown in figure E9-1, what is the beam width? A, 75 degrees, B, 50 degrees, C, 25 degrees, or D, 30 degrees?
Bravo.
Bravo.
Bravo is correct, 50 degrees. So that would be from here to roughly here, where the down 3 dB. In the antenna radiation pattern shown in E9-1, what is the front to back ratio? A, 36 dB, B, 18 dB, C, 24 dB, or D, 14 dB?
Bravo.
Bravo is correct, 18 dB. In the antenna radiation pattern shown in figure E9-1, what is the front to side ratio? A, 12 dB, B, 14 dB, C, 18 dB, or D, 24 dB?
Bravo.
Bravo.
Bravo is correct, 14 dB. What is the radiation resistance of an antenna? A, the combined losses of the antenna elements and feed line. B, the specific impedance of the antenna. C, the value of a resistance that would dissipate the same amount of power as that radiated from an antenna. Or D, the resistance in the atmosphere that an antenna must overcome to be able to radiate a signal.
Charlie.
Charlie is correct. The value of a resistance that would dissipate the same amount of power as that radiated from an antenna. What is included in the total resistance of an antenna system? A, radiation resistance plus space impedance. B, radiation resistance plus transmission resistance. C, transmission line resistance plus radiation resistance. Or D, radiation resistance plus loss resistance.
Delta.
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 Delta is correct. Which of the following factors affect the feed point impedance of an antenna? A, transmission line length. B, antenna height. C, the settings of an antenna tuner at the transmitter. Or D, the input power level.
Bravo.
Bravo.
Bravo is correct, the antenna height. What is antenna efficiency? A, radiation resistance divided by transmission resistance. B, radiation resistance divided by total resistance. C, total resistance divided by radiation resistance. Or D, effective radiated power divided by transmitter output.
Bravo.
Correct answer is Bravo. Radiation resistance divided by total resistance. Okay, eye chart number 2, antenna pattern with mix of ground systems and ground connections. 12 questions. What is the front to back ratio of the radiation pattern shown in figure E9-2? A, 15 dB, B, 28 dB, C, 3 dB, or D, 38 dB?
Bravo.
Correct answer is Bravo, 28 dB. What type of antenna pattern is shown in figure E9-2? A, elevation, B, azimuth, C, radiation resistance, or D, polarization?
Alpha.
Alpha is correct. That is the elevation. What is the elevation angle of peak response in the antenna radiation pattern shown in figure E9-2? A, 45 degrees, B, 75 degrees, C, 7.5 degrees, or D, 25 degrees?
Charlie.
Charlie.
I hear a Charlie there. Correct. 7.5 degrees. What is antenna bandwidth? A, antenna length divided by the number of elements. B, the frequency range over which an antenna satisfies a performance requirement. C, the angle between the half-power radiation points. Or D, the angle formed between two imaginary lines drawn through the element ends.
Bravo.
Bravo is correct. The frequency range over which an antenna satisfies a performance requirement. What happens as the Q of an antenna increases? A, SWR bandwidth increases. B, SWR bandwidth decreases. C, gain is reduced. Or D, more common mode current is present on the feed line.
Bravo.
Bravo is correct. The SWR bandwidth decreases. Which of the following improves the efficiency of a ground-mounted quarter-wave vertical antenna? A, installing a radio system. B, isolating the coax shield from ground. C, shortening the radiating element. Or D, all these choices are correct.
Alpha.
Alpha is correct, installing a radio system. Which of the following factors determines ground losses for a ground-mounted vertical antenna operating in the 3 MHz to 30 MHz range? A, the standing wave ratio. B, distance from the transmitter. C, soil conductivity. Or D, takeoff angle.
Charlie.
Charlie.
Charlie is correct. Soil conductivity. How is the far-field elevation pattern of a vertically polarized antenna affected by being mounted over seawater versus soil? A, the low-angle radiation decreases. B, additional higher vertical angle lobes will appear. C, fewer vertical lobes will be present. Or D, the low angle radiation increases.
Delta.
Delta is correct. The low angle radiation increases. How does the radiation pattern of a horizontally polarized 3-element beam antenna vary with increasing height above the ground? A, the takeoff angle of the lowest elevation lobe increases. B, the takeoff angle of the lowest elevation lobe decreases. C, the horizontal beam width increases. Or D, the horizontal beam width decreases.
Bravo.
Correct
Bravo.
answer is Bravo. The takeoff angle of the lowest elevation lobe decreases. How does the performance of a horizontally polarized antenna mounted on the side of a hill compared with the same antenna mounted on flat ground? A, the main lobe takeoff angle increases in the downhill direction. B, the main lobe takeoff angle decreases in the downhill direction. C, the horizontal beam width decreases in the downhill direction. Or D, the horizontal beam width increases in the uphill direction.
Bravo.
Correct answer is Bravo. Which of the following conductors would be best for minimizing losses in a station's RF ground system? A, resistive wire such as spark plug wire. B, a wide flat copper strap. C, stranded wire. Or D, solid wire.
Bravo.
Bravo is correct. A wide flat copper strap. Which of the following would provide the best RF ground for your station? A, a 50 ohm resistor connected to ground. B, an electrically short connection to a metal water pipe. C, an electrically short connection to 3 or 4 interconnected ground rods driven into the earth. D, an electrically short connection to 3 or 4 interconnected ground rods via a series RF choke.
Charlie.
Charlie is correct. Alrighty, dipole variations, loaded with and traveling wave antennas, 16 questions. Quite an eye chart.
Mhm.
Which of the following is a type of OCFD, off-center fed dipole antenna? A dipole fed approximately 1/3 the way from one end with a 4-to-1 balun to provide multiband operation. B, a remotely tunable dipole antenna using orthogonally, controlled frequency diversity. C, a folded dipole center fed with 300 ohm transmission line. Or D, a multiband dipole antenna using one-way circular polarization for frequency diversity.
Alpha.
Alpha is correct. A dipole fed approximately 1/3 of the way up from one end with a 4-to-1 balun to provide multiband operation. Orthogonally. Okay. I love pronouncing certain words on these tests. What is the approximate feed point impedance at the center of a 2-wire folded dipole antenna? A, 300 ohms. B, 72 ohms. C, 50 ohms. Or D, 450 ohms.
Alpha.
Correct answer is alpha, 300 ohms. What is a folded dipole antenna? A dipole 1/4 wavelength long. B, a type of ground plane antenna. C, a half-wave dipole with an additional parallel wire connecting its two ends. D, a dipole configured to provide forward gain.
Charlie.
Charlie is correct. Hang on. Started to get itchy in the throat. Yuck. Which of the following describes a G5RV antenna? A multiband dipole antenna fed with coax and a balun through a selected length of open wire transmission line. B, a multiband trap antenna. C, a phased array antenna consisting of multiple loops. Or D, a wideband dipole using shorted coaxial cable for the radiating elements and fed with a 4-to-1 balun.
Alpha.
Correct answer is alpha. By the way, curious, anybody running a G5 RV antenna?
Oh,
I do.
Hmm.
I've got one running, and for a while it was a really great antenna, and then the windstorm came along and rainstorm, and I think I may have gotten some rain into it because the SWR all of a sudden started creeping up high. But yeah, it seems to be working okay at my house.
it comes in variable widths of open wire transmission lines too.
Yeah. I bought the full 80 meter G5 RV from MFJ and stuck it up on the peak of the roof and then have it sloping down. And it worked really good for quite a while, and then I think I got some water in there somewhere because now the SWR is high as all get out. Oh well. back to the questions. Which of the following describes a ZEP antenna? A dipole constructed from zip cord. B, an end-fed dipole antenna. C, an omnidirectional antenna commonly used for satellite communications. Or D, a vertical array capable of quickly changing the direction of maximum radiation by changing phase lines.
Bravo.
Bravo is correct. An end-fed dipole antenna. Which of the following describes an extended double ZEP antenna? A wideband vertical antenna constructed from precisely tapered aluminum tubing. B, a portable antenna erected using 2 push support poles. C, an end-fed 1.25 wavelength antenna, 2 5/8 waves element in phase. Or D, an end-fed fold dipole antenna.
Charlie.
Charlie is correct. An end-fed 1.25 wavelength antenna or 2 5/8 wave and elements in phase.
Center fed.
Center fed, sorry about that. Yeah. Wow, my eyes just went. Where should a high Q loading coil be placed? And by the way, that is water that I was drinking. It's not vodka. Where should a high Q loading coil be placed to minimize losses in a shortened vertical antenna? A, near the center of the vertical radiator. B, as low as possible on the vertical radiator. C, as close to the transmitter as possible. Or D, at a voltage node.
Bravo.
Alpha.
Alpha is the correct, near the center of a vertical radiator. Why should an HF mobile antenna loading coil have a high ratio of reactance to resistance? A, to swamp out harmonics. B, to lower the radiation angle. C, minimize losses. Or D, to minimize the Q.
Charlie.
Charlie is correct, to minimize losses. What happens to the SWR bandwidth when one or more loading coils are used to resonate an electrically short antenna? A, it is increased. B, it is decreased. C, it is unchanged if the loading coil is located at the feed point. D, it is unchanged if the loading coil is located at a voltage maximum point. Correct answer is bravo. It is decreased. What is an advantage of using top loading in a shortened HF vertical antenna? A, a lower Q. B, greater structural strength. C, higher losses. Or D, improved radiation efficiency.
Delta.
Correct answer is delta, improved radiation efficiency. What is the function of a loading coil used as part of an HF mobile antenna? A, to increase the SWR bandwidth. B, to lower the losses. C, to lower the Q. Or D, to cancel capacitive reactance.
Delta.
Delta is correct, to cancel capacitive reactance. What happens to feed point impedance at the base of a fixed length HF mobile antenna when operated below its resonant frequency? A, the radiation resistance decreases and the capacitive reactance decreases. B, the radiation resistance decreases and the capacitive reactance increases. C, the radiation resistance increases and the capacitive reactance decreases. Or D, the radiation resistance increases and the capacitive reactance increases.
Bravo.
Bravo is correct. The radiation resistance decreases and the capacitive reactance increases. What happens to the radiation pattern of an unterminated long wire antenna as the wire length is increased? A, the lobes become more perpendicular to the wire. B, the lobes align more in the direction of the wire. C, the vertical angle increases. D, the front to back ratio decreases.
Bravo.
Bravo is correct. The lobes align more in the direction of the wire. What is the effect of adding a terminating resistor to a rhombic antenna? A, it reflects the standing waves on the antenna elements back to the transmitter. B, it changes the radiation pattern from bidirectional to unidirectional. C, it changes the radiation pattern from horizontal to vertical polarization. Or D, it decreases the ground loss.
Bravo.
Hang on real quick. There we go. Bravo is correct. Set up my presentation screen. When constructing a beverage antenna, which of the following factors should be included in the design to achieve good performance at the desired frequency? A, its overall length must not exceed 1/4 wavelength. B, it must be mounted more than one wavelength above the ground. C, it should be configured as a 4-sided loop. Or D, it should be one or more wavelengths long.
Delta.
Delta is correct. It should be one or more wavelengths long, which is generally true for a low band 160 meter and 80 meter receiving antenna. A, atmospheric noise is so high that gain over a dipole is not important. B, they must be erected at least 1/2 wavelength above the ground to attain good directivity. C, low loss coax transmission line is essential for good performance. D, all these choices are correct.
Alpha.
Alpha is correct. Atmospheric noise is so high that gain over a dipole is not important. All right, practical antennas, 7 last questions. Phased arrays and antennas for space communication. What is the radiation pattern of two 1/4 wavelength vertical antennas spaced 1/2 wavelength apart and fed 180 degrees out of phase? A, cardioid. B, omnidirectional. C, a figure-8 broadside to the axis of the array. Or D, a figure-8 oriented along the axis of the array.
Charlie.
Delta is the correct. A figure-8 oriented along the array axis, or the axis of the array. What is the radiation pattern of two 1/4 wavelength vertical antennas spaced 1/4 wavelength apart and fed 90 degrees out of phase? A cardioid, B, a figure 8 end fire along the axis of the array, C, a figure 8 broadside to the axis of the array, or D, omnidirectional.
Delta.
Alpha is the correct answer. It's a cardioid. This was the one with all of the little patterns on it, and unfortunately I haven't memorized them either. What is the radiation pattern of two 1/4 wavelength vertical antennas spaced 1/2 wavelength apart and fed in phase? A, omnidirectional, B, cardioid, C, a figure 8 broadside to the axis of the array, or D, a figure 8 end fire along the axis of the array.
Charlie?
Charlie is correct. A figure 8 broadside to the axis of the array. What is a use for a Wilkinson divider? A, it divides the operating frequency of a transmitter signal so it can be used on a lower frequency band. B, it is used to feed high impedance antennas from a low impedance source. C, it is used to divide power equally between two 50 ohm loads while maintaining 50 ohms input impedance. Or D, it is used to feed low impedance loads from a high impedance source.
Charlie.
Charlie is correct. It is used to divide power equally between two 50 ohm loads while maintaining the 50 ohm input impedance. What is the primary purpose of phasing lines when used with an antenna having multiple driven elements? A, it ensures that each driven element operates in concert with the others to create the desired antenna pattern. B, it prevents reflected power from traveling back down the feed line and causing harmonic radiation from the transmitter. C, it allows single band antennas to operate on other bands. Or D, it creates a low angle radiation pattern.
Alpha.
Alpha is correct. Much is the gain of an ideal parallel dish antenna change when the frequency is doubled? A, 2 dB, B, 3 dB, C, 4 dB, or D, 6 dB.
Delta.
Delta is correct. How can linearly polarized Yagi antennas be used to produce circular polarization? A, stack two Yagis fed 90 degrees out of phase to form an array with the respective elements in parallel planes. B, stack two Yagis fed in phase to form an array with the respective elements in parallel planes. C, arrange two Yagis perpendicular to each other with the driven elements at the same point on the boom, fed 90 degrees out of phase. Or D, arrange two Yagis collinear to each other with the driven elements fed 180 degrees out of phase.
Charlie.
Charlie.
Charlie is correct. On the same boom, fed 90 degrees out of phase.
Did everybody know that the term Yagi is the actual name of a person?
One of the two persons, Yagi and Uda.
That's right.
Beverage.
Yeah, that's Mr. Beveridge.
Speaking of beverage, hang on. I see what Daniel means that was telling me about. Your voice is going to go out eventually. All right, practical antennas. I lied. Receiving loop antennas for direction finding. I think this might be the last of practical antennas. What is receiving directivity factor, RDF? A, forward gain compared to the gain in the reverse direction. B, relative directivity compared to isotropic. C, relative directivity compared to a dipole. Or D, forward gain compared to average gain over the entire hemisphere.
Delta.
Delta is correct. Forward gain compared to average gain over the entire hemisphere. What is an advantage of placing a grounded electrostatic shield around a small loop direction finding antenna? A, it adds capacitive loading, increasing the bandwidth of the antenna. B, it eliminates unbalanced capacitive coupling to the surroundings, improving the nulls. C, it eliminates tracking errors caused by strong out-of-band signals. Or D, it increases signal strength by providing a better match to the feed line.
Bravo.
Bravo is correct. It eliminates unbalanced capacitive coupling to the surroundings, improving your nulls. What is the main drawback of a small wire loop antenna for direction finding? A, it has a bidirectional pattern. B, it has no clearly defined null. C, it is practical for use only on VHF and higher bands. Or D, all these choices are correct.
Alpha.
Alpha.
Alpha is correct. It has a bidirectional pattern. What is the triangulation method of direction finding? A, geometric angles of skyways from the source are used to determine its position. B, a fixed receiving station plots 3 headings to the signal source. C, antenna headings from several different receiving locations are used to locate the signal source. Or D, a fixed receiving station uses 3 different antennas to plot the location of signal source.
Charlie.
Charlie is correct.
So why can't you use C if you've got multiple antennas at different directions that are far away from the receiving station? I guess that's for another conversation, but yeah, you're right.
Why is RF attenuation used when direction finding? A, to narrow the receiver bandwidth. B, to compensate for isotropic directivity and the antenna effective feed lines. C, to increase receiver sensitivity. Or D, to prevent receiver overload, which reduces pattern nulls.
Delta.
Delta is correct. Prevent the receiver overload, which reduces pattern nulls. What is the function of a sense antenna? A, it modifies the direction of an DF antenna array to provide a null in one direction. B, it increases the sensitivity of a DF antenna array. C, it allows DF antennas to receive signals at different vertical angles, or D, it provides diversity reception that cancels multipath signals.
Alpha.
Alpha is correct. It modifies the pattern of a DF antenna array to provide a null in one direction. What is a pennant antenna? A 4-element high-gain vertical array invented by George Pennant. B, a small vertically oriented antenna, receiving antenna consisting of a triangular loop terminated in approximately 900 ohms. C, a form of rhombic antenna terminated in a variable capacitor to provide frequency diversity. Or D, a stealth antenna built to look like a flagpole.
Bravo.
Correct answer is Bravo. How can the output voltage of a multiple turn receiving loop antenna be increased? A, by reducing the permeability of the loop shield. B, by utilizing high impedance wire for the coupling loop. C, by winding adjacent turns in opposite directions. Or D, by increasing the number of turns and or the area.
Delta.
Delta is correct, by increasing the number of turns and or the area. What feature of a cardioid pattern antenna makes it useful for direction finding? A, a very sharp peak. B, a very sharp single null. D, broadband response. Or D, high radiation angle.
Bravo.
Bravo.
Bravo is correct, a very sharp single null. Antenna systems, 11 questions, and there will be continuations. Effective radiated power and impedance matching is this first section. What is the effective radiated power relative to a dipole of a repeater station with 150 watts transmitter power output, a 2 dB feed line loss, a 2 dB multiplexer loss, and a 7 dBd antenna gain? A, 1977 watts. B, 78.7 watts. C, 420 watts. D, 286 watts.
Delta.
Delta is correct, 286 watts. What is the effective radiated power relative to a dipole of a repeater station with 200 watts transmitted output power, 4 dB feed line loss, 3.2 dB duplexer loss, 0.8 dB circulator loss, and a 10 dBd antenna gain? A, 317 watts. B, 2000 watts. C, 126 watts. Or D, 300 watts.
Alpha.
Alpha is correct, 317 watts. What is the effective isotropic radiated power of a repeater station with 200 watts transmitter output power, 2 dB feed line loss, 2.8 dB duplexer loss, 1.2 dB circulator loss, and a 7 dBi antenna gain? A, 159 watts. B, 252 watts. C, 632 watts. Or D, 63.2 watts.
Bravo.
Bravo.
I heard 2 Bravos in there. 252 watts is correct. What term describes station output taking into account all gains and losses? A, power factor. B, half power bandwidth. C, effective radiated power. Or D, apparent power.
Charlie.
Charlie is correct. Your effective radiated power. What system matches a higher impedance transmission line to a lower impedance antenna by connecting the line to the driven element in 2 places spaced a fraction of a wavelength each side of the element center? A gamma match system. B, a delta matching system. C, the omega matching system. Or D, the stub matching system.
Bravo.
Bravo is correct, a delta matching system. What is the name of an antenna matching system that matches an unbalanced feed line to an antenna by feeding the driven element both at the center of the element and at a fraction of a wavelength to one side of the center? A, the gamma match. B, the delta match. C, the epsilon match. Or D, the stub match.
Alpha.
Alpha is correct, a gamma match. What is the name of a matching system that uses a section of transmission line connected in parallel with the feed line at or near the feed point? A, the gamma match. B, the delta match. C, the omega match. Or D, the stub match.
The cage match.
The what match?
The cage match.
D, the stub match is correct.
Only when you wrestle with your antenna.
What is the purpose of the series capacitor in a gamma match antenna matching network? A, to provide DC isolation between the feed line and the antenna. B, to cancel the inductive reactance of a matching network. C, to provide a rejection notch that prevents the radiation of harmonics. Or D, to transform the antenna impedance to a higher value.
Bravo.
Bravo is correct, to cancel the inductive reactance of the matching network. How must an antenna's driven element be tuned to use a hairpin matching system? A, the driven element's reactance must be capacitive. B, the driven element's reactance must be inductive. C, the driven element's resonance must be lower than the operating frequency. Or D, the driven element's radiation resistance must be higher than the characteristic impedance of the transmission line.
Alpha.
Correct answer is alpha. The driven element's reactance must be capacitive. Which of the following is used to shunt feed?
Yeah, I think your page on the last question was wrong.
Let me write it down.
E9E05 is on.
I have it as 926.
Yeah, you have 938.
E9E05 page is, what's the correct page?
I think 926. But I may be wrong.
I
That's
agree.
right.
No, you're
That's
right.
That's right.
What is it, 926?
Yes.
and E05. Yep, I see it there. Thank you. Okay. Which of the following is used to shunt feed a grounded tower at its base? A double bazooka match. B, a hairpin match. C, a gamma match. Or D, all these choices are correct.
C, gamma.
Charlie.
Gauge.
Charlie.
Charlie, a gamma match is correct.
And page number correction there too.
Yeah.
Now that you have me looking at it. On 9-26.
Okay. Well, these are from ARRL, so they must have scanned them in wrong or did their lookups wrong. Thanks for that. Oh, yeah. Which of the following is a common use for a Smith chart? A, determine the length and position of an impedance matching stub. B, determine the impedance of a transmission line given the physical dimensions. C, determine the gain of an antenna given the physical and electrical parameters. D, determine the per 100 feet of a transmission line given the velocity factor and conductor materials.
Alpha.
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 Alpha is correct. Determine the length and position of an impedance matching stub. Boy, that's another eye chart. See, I tried to stuff as much as I could, and I managed to do so. Velocity factor and electrical length, feed line loss, reflection coefficient and SWR, and power measurement. 11 questions. What is the velocity factor of a transmission line? A, the ratio of the characteristic impedance of the line to the terminating impedance. B, the index of shielding for coaxial cable. C, the velocity of the wave in the transmission line multiplied by the velocity of light in a vacuum. D, the velocity of the wave in a transmission line divided by the velocity of light in a vacuum.
Delta.
Delta is correct. The velocity of wave in a transmission line divided by the velocity of light in a vacuum. Which of the following has the biggest effect on the velocity factor of a transmission line? A, the termination impedance. B, the line length. C, the dielectric materials used in the line. Or D, the center conductor resistivity.
Charlie.
Charlie is correct. The dielectric materials used in the line. Why is the physical length of a coaxial cable transmission line shorter than its electrical length? A, skin effect is less pronounced in the coaxial cable. B, the characteristic impedance is higher in a parallel feed line. C, surge impedance is higher in a parallel feed line. D, electrical signals move more slowly in a coaxial cable than in air.
Delta.
Delta is correct. The electrical signals move more slowly in a coaxial cable than in air. What is the approximate physical length of a solid polyethylene dielectric coaxial transmission line that is electronically 1/4 wavelength long at 14.1 megahertz? A, 10.6 meters. B, 5.3 meters. C, 4.3 meters. Or D, 3.5 meters.
Delta.
Delta is correct, 3.5 meters. What is the approximate physical length of an air-insulated parallel conductor transmission line that is electronically 1/2 wavelength at 14.10 megahertz? A, 7.0 meters, B, 8.5 meters, D, 10.6 meters, or D, 13.3 meters?
Charlie.
Bravo.
Charlie is the correct 10.6 meters. What is the approximate physical length of a foam polyethylene dielectric coaxial transmission line that is electrically 1/4 wavelength long at 7.2 megahertz? A, 10.4 meters, B, 8.3 meters, C, 6.9 meters, or D, 5.2 meters?
Bravo.
Bravo is correct, 8.3 meters. How does ladder line compare to small diameter coaxial cable such as RG58 at 50 megahertz? A, lower loss, B, higher SWR, C, smaller reflection coefficient, or D, lower velocity factor?
Alpha.
Alpha is correct, a lower loss. Which of the following is a significant difference between foam dielectric coaxial cable and solid dielectric cable, assuming all other parameters are the same? A, foam dielectric is lower safe operating voltage limits. B, foam dielectric has lower loss per unit of length. C, foam dielectric has higher velocity factor. Or D, all these choices are correct.
Delta.
Delta, all these choices are correct. What parameter describes the interactions at the load end of a mismatched transmission line? A, characteristic impedance, B, reflection coefficient, C, velocity factor, or D, dielectric constant?
Bravo.
Bravo is correct, the reflection coefficient. How much power is being absorbed by the load when a directional power meter connected between a transmitter and a terminating load reads 100 watts forward power and 25 watts reflected power? A, 100 watts, B, 125 watts, C, 25 watts, or D, 75 watts? Correct answer is delta, 75 watts. What is indicated if the current reading on a RF ammeter placed in series with the antenna feed line of a transmitter increases as the transmitter is tuned to resonance? A, there's probably a short to ground in the feed line. B, the transmitter is not properly neutralized. C, there is an impedance mismatch between the antenna and the feed line. D, there is more power going into the antenna.
Delta.
Delta is correct. There is more power going into the antenna. Transmission lines continued. Smith charts, 10 questions. Which of the following can be calculated using a Smith chart? A. Impedance along transmission lines. B. Radiation resistance. C. Antenna radiation pattern. Or D. Radio propagation.
Alpha.
Alpha is correct. The impedance along transmission lines. What type of coordinate system is used in a Smith chart? A. Voltage circles and current arcs. B. Resistance circles and reactance arcs. C. Voltage lines and current cords. D. Resistant lines and reactance cords.
Bravo.
Bravo is correct. The resistance circles and the reactance arcs. Which of the following is often determined using a Smith chart? A. Beam headings and radiation patterns. B. Satellite azimuth and elevation bearings. C. Impedance and SWR values in transmission lines. Or D. Trigonomic functions.
Charlie.
That's correct. Trigonomic functions, Charlie. Impedance and SWR values in transmission lines. I love some of these. The satellite azimuth and elevation. Yeah, we'll use that Smith chart. What are the two families of circles and arcs that make up a Smith chart? A. Resistance and voltage. B. Reactance and voltage. C. Resistance and reactance. Or D. Voltage and impedance.
Charlie.
Charlie is correct. Resistance and reactance. On the Smith chart shown in figure E9-3, what is the name for the large outer circle on which the reactance arcs terminate? A. The prime axis. B. Reactance axis. C. Impedance axis. Or D. Polar axis.
Bravo.
Bravo is correct. The reactance axis. On the Smith chart shown in figure E9-3, what is the only straight line shown? A. The reactance axis. B. The current axis. C. The voltage axis. Or D. The resistance axis.
Okay.
Delta.
Delta is correct. The resistance axis. What is the process of normalization with regard to a Smith chart? A. Reassigning resistance values with regard to the reactance axis. B. Reassigning reactance values with regards to the resistance axis. C. Reassigning impedances with regard to the prime center. Or D. Reassigning prime center with regard to the reactance axis.
Charlie.
Charlie is correct. Reassigning the impedance values with regard to the prime center. What third family of circles is often added to the Smith chart during the process of solving problems? A. Standing wave ratio circles. B. Antenna length circles. C. Coaxial length circles. Or D. Radiation pattern circles.
Alpha.
Correct answer is alpha, standing wave ratio circles. What do the arcs on a Smith chart represent? A. Frequency. B. SWR. C. Points with a constant resistance. D. Points with constant reactance.
Delta.
Delta.
Delta is correct. Points with constant reactance. How are the wavelength scales on a Smith chart calibrated? A, in fractions of transmission line electrical frequency. B, in fractions of transmission line's electrical wavelength. C, in fractions of the antenna electrical wavelength. D, in fractions of antenna electrical frequency.
Bravo.
Bravo is correct. In fractions of transmission line electrical wavelengths. Transmission lines continued. Transmission line stubs and transformers and scattering S parameters. Which of these feed line impedances would be suitable for constructing a quarter wave Q section for matching 100 ohm loop to a 50 ohm feed line? A, 50 ohms. B, 62 ohms. C, 75 ohms. Or D, 450 ohms.
Charlie.
Charlie.
I heard Charlie out there. 75 ohms. Correct. Which of these choices is an effective way to match an antenna with a 100 ohm feed point impedance to a 50 ohm coaxial feed line? A, connect a 1/4 wavelength open stub of 300 ohm twin lead in parallel with the coaxial feed line where it connects to the antenna. B, insert a 1/2 wavelength piece of 300 ohm twin lead in series with the antenna terminals and the 50 ohm feed cable. C, insert a 1/4 wavelength piece of 75 ohm coaxial cable transmission line in series between the antenna terminals and the 50 ohm feed cable. Or D, connect a 1/2 wavelength shorted stub of 75 ohm cable in parallel with the 50 ohm cable where it attaches to the antenna.
Charlie.
Correct answer is Charlie.
You think you can repeat all those answers again, Jim?
Page number error there too.
Go a little faster next time, okay?
Rubber baby bumpers. What is the correct page? E9,
E9.
E10.
E10 should be 938.
Yes.
All righty, thank you. What impedance does a 1/2 wavelength transmission line present to a generator when the line is shorted at the far end? A, very high impedance. B, very low impedance. C, the same as the characteristic impedance of the line. Or D, the same as the output impedance of the generator.
Charlie.
Baker, Bravo is
No,
the
I
correct,
got
a
it wrong.
very low impedance. What impedance does a 1/8 wavelength transmission line present to a generator when the line is shorted at the far end? A, capacitive reactance. B, the same as the characteristic impedance of the line. C, an inductive reactance. Or D, 0.
Charlie.
Correct answer is Charlie, an inductive reactance. What impedance does a 1/8 wavelength transmission line present to a generator when the line is open at the far end? A, the same as the characteristic impedance of the line. B, an inductive reactance, C, a capacitive reactance, or D, infinite?
Charlie.
Charlie is correct, a capacitive reactance. What impedance does a 1/4 wavelength transmission line present to a generator when the line is open at the far end? A, the same as the characteristic impedance of the line. B, the same as the input impedance to the generator. C, very high impedance. Or D, very low impedance.
Delta.
Delta.
Delta is correct, very low impedance. What impedance does a 1/4 wavelength transmission line present to a generator when the line is shorted at the far end? A, very high impedance. B, very low impedance. C, the same as the characteristic impedance of the transmission line. Or D, the same as the generator output impedance.
Alpha.
Alpha is correct, a very high impedance. Which S parameter is equivalent to forward gain? A, S11, B, S12, C, S21, or D, S22?
Charlie.
Charlie is correct, the S21 parameter. Which S parameter represents input port return loss or reflection coefficient, or equivalent to the VSWR? A, the S11, B, the S12, C, the S21, or D, the S22?
Oh,
Alpha is correct, the S11 parameter. What do the subscripts of S parameters represent? A, the port or ports at which the measurements are made. B, the relative time between measurements. C, relative quality of data. Or D, the frequency order of the measurements.
Alpha.
Alpha is correct, the port or ports at which the measurements are made. 9.4 transmission lines, antenna, and network analyzers. Which of the following is an advantage of using an antenna analyzer compared to an SWR bridge to measure antenna SWR? A, antenna analyzers automatically tune your antenna for resonance. B, antenna analyzers do not need an external RF source. C, antenna analyzers display a time-varying representation of the modulating envelope. D, all these choices are correct.
Bravo.
Bravo is correct. The antenna analyzers do not need an external RF source. Which of the following measures SWR? A, a spectrum analyzer. B, a Q meter. C, an ohm meter. Or D, an antenna analyzer.
Delta.
Delta is correct. The antenna analyzer measures SWR. How should an antenna analyzer be connected when measuring antenna resonance and feed point impedance? A, loosely couple the analyzer near the antenna base. B, connect the analyzer via a high impedance transformer to the antenna. C, loosely couple the antenna and a dummy load to the analyzer. D, connect the antenna feed line directly to the analyzer's connector. Correct answer is delta. Connect the antenna feed line directly to the analyzer's connector. What three test loads are used to calibrate an RF vector network analyzer? A, 50 ohms, 75 ohms, and 90 ohms. B, short circuit, open circuit, and 50 ohms. C, short circuit, open circuit, and resonant circuit. D, 50 ohms through 1/8 wavelength, 1/4 wavelength, and 1/2 wavelength of coaxial cable.
Bravo.
Bravo, correct. A short circuit, an open circuit, and a 50 ohms.
So what would 75 ohms indicate in your SWR meter?
75 ohms is that the open?
No, it's not open because it's 75 ohms.
Oh, that's right.
Just
Because I
calibration words.
actually use three of them: open, short, 50, and 75, to make sure my meter is stable over its entire range. What does 75 ohms tell you as far as an SWR? Bill, I saw your mouth open.
Fill us in, Mark.
You can use it to check your 1.5 to 1 SWR.
Ah, okay. Thank you, sir.
It's not misleading, but yeah, the B is correct as far as to calibrate.
Yeah, that's the only ones that I've ever had was the short, open, and 50 ohm load. I haven't, and I've got two of the Vector network. Two very cheap ones, by the way. But nonetheless, they're a lot of fun. All righty. Which of the following can be measured with a vector network analyzer? A, input impedance. B, output impedance. C, reflection coefficient. Or D, all these choices are correct.
Delta.
Delta, all these choices are correct. 9.5, antenna design. Just 4 questions, antenna modeling and design. What type of computer program technique is commonly used for modeling antennas? A, graphical analysis. B, the method of moments. C, mutual impedance analysis. D, calculus differentiation with respect to physical properties.
Bravo.
Bravo.
Bravo is correct. The method of moments. What is the principle of a method of moments analysis? A wire is modeled as a series of segments, each having a uniform value of current. B, a wire is modeled as a single sine wave current generator. C, a wire is modeled as a single sine wave voltage source. D, a wire is modeled as a series of segments, each having a distinct value of voltage across it.
Alpha.
Alpha.
Alpha is correct. A wire is modeled as a series of segments, each having a uniform value of current. What is the disadvantage of decreasing the number of wire segments in an antenna model below 10 segments per half wavelength? A, ground conductivity will not be accurately modeled. B, the resulting design will favor radiation of harmonic energy. C, the computed feed point impedance may be incorrect. D, the antenna will become mechanically unstable.
Charlie.
Charlie is correct. The computed feed point impedance may be incorrect. What usually occurs if a Yagi antenna is designed solely for maximum forward gain? A, the front to back ratio increases. B, the front to back ratio decreases. C, the frequency response is widened over the whole frequency band. Or D, the SWR is reduced.
Bravo.
Bravo is correct. The front to back ratio decreases. Dib, 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 dib. That's all, folks. Hoorah! The screen sharing has stopped. The shared window is closed. Yep, I closed the window. Phew! That felt like a long chapter
Yeah.
compared to some of the others. I
It
guess
was.
guess I'll have to do some more calculating on the first few chapters, but that one seemed a really long one.
And he
I think
jumped
it's the
all
longest
around.
one.
I was
Yeah.
really disappointed. They didn't give me a lot of questions that had calculations in them.
Didn't need my slide rule once, right?
Yeah.
Do we have a confirmation on testing date yet?
No, yeah, I need to follow up with Scott. Right now he has the 22nd, but there's only 3 slots, so I need to get him to carve up a few private slots that aren't advertised on the internet, but that you guys can go to it. He when I send out the next update with the links and all for the video, for those that want to do the test right away, can you reply to me and let me know? Because when I did the tech and the general, there was a few people that said, no, I'm going to wait, a couple of weeks before we do it. And that kind of poo-pooed some of the carving off of or saving stats on the Zoom. So I fell out of grace, so to speak, with Scott, because he and rightly so, he had to get 4 other people to sign up to do the Zoom meetings, and luckily I think they when he opened it up to the internet and let everybody advertise them, hopefully they all got used. I've already had a few techs and generals pass their thing, but I did get quite a few people that said, oh no, we want to work on it a couple more weeks before we do things. So when I send out the update with the link and also the reminder that we're going to do next week is going to be the last class, and we'll do the chapter 10 and 11 together, because it's only 45 in 10 and 11 in 11, so 56 questions and like 90 minutes of video. So we should finish up pretty early next week on the final class, and we'll do a couple of sample test runs, one with the ARRL and one with the ham study one, just for fun. But when I send out the links, let me know who really wants to test, like Johnny, in the next week or so. And I know that Daniel isn't online tonight, but I know he was going to try to get some in-person places going, but I haven't heard back from him on if he's going to get that done. So when I send that out, let me know if you're interested in doing it right away or be more interested in not doing it in the Zoom format, because rumor is that he's only allowing a half an hour, which to me, that's not enough time for an extra class exam. So I don't know how many people are going to want to try to stuff everything into a half an hour.
There's no thumbs down emoji or reaction.
Yeah.
How about crying? How's that?
How
Yeah.
much time is devoted to a regular in-person session for exam testing?
What was that?
It's Joe,
Yeah,
and I want to know how much time is usually allocated for in-person extra exam testing.
okay, so yeah, on the in-person, if it's with Daniel, it's as long as it takes you. We're there. And we don't rush people. And that was the thing that I liked about Daniel is when you're in person, he just says, take your time, don't rush it, figure it out, and turn it in when you're ready to turn it in. So I know that he had said originally from 2 in the afternoon to 6 in the afternoon, so that was 4 hours. So 4 hours for 50 questions. So hopefully that's all I've got. So
Thanks, Jim. I'm out of here.
Thank you.
Thanks a lot.
Thank you.
thanks for showing up tonight, and one more week, then we'll get some practice tests going.
Thanks. Bye-bye.
Bye.
Okay.
Thanks for
Thanks
that.
everybody. I'm going to stop the recording.